Hello, good morning. It's me, Develop Nuri, student of International School of Management team affiliated to Sunderland University. My ID is 2200766041. In this presentation, I will demonstrate the early diabetes prediction using different models. Okay, for that, I use Brave browser. First, open Jupyter. Open my project from desktop, assignment AI, and this is the project. In this project, I choose this topic because many people are suffering from diabetes nowadays. The main goal of this topic is to raise the awareness and understanding, allowing the proactive health management towards the patient. And uh, here I mention the different major factors which affect the diabetes, which I will mention below. Here I am exploring the data set of 1 lakhs data from Kaggle base based on age, glucose level, gender, hypertension or disease, and smoking history, and finally body mass BMI. Uh, in this project, I uses histogram, box plots, and pie charts that represent the density and values. Uh, Here I have imported the libraries such as pandas libraries and numpys. From here, I uses the dataset, that is diabetes prediction dataset CV, which is stored in DF. If I continue from DF.8 uh, 5, it will show that the 5 rows, and based on gender, age, hypertension or disease, smoking history, BMI, SBA1C level, blood glucose level, and diabetes. In this line 4, df.shape is initialized in df underscore shape, and if I print the underscore shape, it will show that the 1 lakh data with 9 columns are shown in my data set. And this is for the smoking history, and if I print the smoking history column, it will show that the data is based on gender, age, hypertension or disease, smoking history, BMI, SB1C level, blood glucose level, diabetes. Now here we can see the data, and here we inserted the smoking history values such as neighbor, no info, current, former, ever, and not current. Here is the data which I haven't inserted before, and this is the standard chart, and this is the category aid in diabetes prediction, and this is the diabetes data. Here I have represent diabetes by 1 and not diabetes by 0, and this is the TSN work. Basically the TSN is the capture of visualization complex relationship between the data points with in a lower dimensional space. It is the data visualization and explorer helping to uncover pattern and structure in high dimensional to low dimensional in original space. Here is the code, and uh, in this diabetes prediction, I use TSN component 1 to the x-axis and TSN component to the y-axis, component 2 on the y-axis, and here is the red dot and blue dot, where red dot represent the people who are suffering from diabetes and the blue dot is normal. Here the color contrast is also shown that the if color is uh, rapidly changing from blue to red, which indicates that the people are uh, slowly slowly getting diabetes from 0 to 1. And these are the observation. Here we can see there in 1 are the 2 cluster point, where we can see at the image in the top, and the 2 color so still underlying the data. These are the data which are being predict using using this data set, and this is our heat map. Heat map is predict based on diabetes and blood glucose level, BMI level, and so on. If the color is increasing, this chart represents the correlation coefficient between columns along with the main diagonal. The dark color shows the strong correlation between these, such as diabetes and blood glucose level. There is BMI level and diabetes is 0.21, and heart disease and BMI is 0.06. Similarly, from here we can print the size of the data, that is 1 lakh, and here I import the code which shows the histogram of diabetes data based on density and values, and histogram is based on density and box plot is based on values. Similarly, this is the diagram of BMI level, and this is third one is SB1C level, and the fourth one is on blood glucose level. From here, from this code, I have implemented the bar chart of based on gender, that 0 represent the female and 1 represent the male. This is in the y-axis. I included the count, and x-axis is the gender. It shows that the male is more getting diabetes than female based on gender. If I evaluate the same data from hypertension, the female is more as compared to male, and this is the based on heart disease, and this is the based on smoking disease, and there are different type of color are shown which indicate that the people are slightly suffering from normal people to diabetes, and this is the based on diabetes, that is female and male. Here we have seen that the image is based on gender, that the 0 represent the female and 1 represent the male. This image is represented on hypertension, and this pie chart is represent in heart disease. Here we can see the data based on gender is hypertension and so on, and this is based on smoking history, that the slightly the people are suffering from diabetes, that now at first there is 35.8% people are normal, and then completely diabetes people are 35.1%. Slightly the process of diabetes is being increased by 4%, 6.4, 9.3, and 9.4%. Here is the data which I have been mentioned, and this chart represent the BMI level, and this shows the SBMI level, which is overriding the data, which is so small, and this is based on blood glucose level, and this pie chart represent that the overall 91.5% are normal, whereas 8.5% people are getting diabetes. From here, there are many patients which are being analyzed through the bar graph and pie chart from different aspects. Among them, people suffering from smoking history and blood glucose level, SB1C, are more affected and are more diabetes. From here, the machine learning is started based on test and train. First, we train the data, and then we test the data, and we split and test the data using different algorithm. Our first model is regression model. First, we create the model and import the model, train that x-train and y-train, store in log regress. Here we can see that the accuracy is measured based on precision, recall, F1 score, and support. Here we can see the F1 score is scored 0.96, that is 96%. Similarly, if we check the cross validation score of logistic regression, we can see the different data are present with mean value and median value. From here we can say that the accuracy is slightly median is more accurate as compared to median and cross validation accuracy. And the next one is randomized search CB. From here we can from here I uses the different parameter grid C, penalty, solver, and maximum iterator, and the best cross validation score is 96%. And last one of this model is confusion matrix. Second last of this model is the confusion matrix. From this confusion matrix, it is predict that the best threshold value is 0.1 and the maximum sensitivity is 0.8. Now again we have done train this data, and in this confusion matrix, here we can see at the y-axis that is the actual data, and at the x-axis that is the predict data. This box represents the actual negative data, and this box represents the actual positive data, and this represents the predicted positive data. And from here we can predict the accuracy using this formula TP plus TN divided by TP plus FN plus TN plus FN, where TP represents the truly positive, TN represents the truly negative, FP is falsely positive, and FN is falsely negative. And another is the ROC curve, where ROC curve is presented x-axis on the false positive rate and y-axis on the true positive rate. Here we can see the only 96% accuracy is obtained from the logistic regression using ROC, area under curve. And the second one is the train the value using ROC. Here we can see the we train the value using ROC, that is 96%, and I plot that image on histogram. In this histogram, I uses frequency on the y-axis and ROC value on the x-axis. Here we can see the accuracy is slightly increasing, and at this point 0.961% there is the maximum number of accuracy, and then it is slightly decreasing. And this is the image of box plot, which is also same. And this is the value based on coefficient, standard error, and wall statistics based on age, BMI, HbA1c level, blood glucose level, gender, hypertension or disease, and smoking history. And the second model is the k-nearest model. I created the k-nearest model, trained the data over here, and this is the code of ROC curve. Here we can see there is only 90.5% accuracy is obtained from the AOROC, that is area under curve, which I have posted y-axis on truly positive rate and x-axis on falsely positive rate. And our next one is classification report. In this classification report, there is precision, recall, F1 score, and support. Here we can see the accuracy is 96% obtained from F1 score. And another one is cross validation score. Here we can see the mean, median accuracy with cross validation score. And another one is randomized CB. Here we this is my random search CB based on K-Neighbor classifier, and this is the hyperparameter I use, and this is the cross validation score, that is 96%. And here I have trained the K-Neighbor's classifier data, and this is the confusion matrix code. Here we can see the confusion matrix, based on actual and predicted data. In above, I have shown that how we can calculate the confusion matrix data using confusion matrix accuracy data. And our next one is decision tree classifier. I have trained the data based on X-train and Y-train, create the classifier, and here I uses the ROC curve. In this ROC curve, there is 89% accuracy based on true positive rate and false positive rate. It can say that if the accuracy is more, then it is the best. If the accuracy is slightly less, then it is said that that is not perfect for this model. And this is the decision tree classifier report, and there we can see the precision, recall, F1 score, and support. Their accuracy is 97%. And the next one is cross validation based on decision tree. Here we can see the cross validation score and the mean accuracy and median accuracy. Then the third one is random CV. Here in their parameter grid, I have using the criticism, splitter, maximum depth, minimum sample split, minimum sample leaf, maximum features, and random states. That is the output. And their best cross validation score is 97%. And third one is the decision tree classifier using the confusion matrix. Here we can see this is our confusion matrix. And the next one is random forest classifier. Here I created the random forest classifier based on X-train and Y-train. And this is our ROC curve, which proves the 0.96 percent, that is 96% accuracy based on true positive rate and false positive rate. And this is the classifying report. Here we can see that it is 97% accuracy is obtained in F1 score using random forest. And the third one is the cross validation score. Here we can see the cross validation score is score that is 97%, sorry, 0.972875. Similarly, here we can see the other value as well. Here is the mean value and median value. And this is the confusion matrix code, and this is the image. To compare all these models with different techniques, it concludes that AURC obtained less accuracy between 94% to 96%, whereas mean accuracy scored the higher accuracy of 97.1578%. Thank you. This is my presentation. Have a good day.